Hello everyone. In this video, we are going to talk about Lab 3, electrical circuits and components. In introduction part, you can see that there are two different parts for this lab, part A and B. In part A, you will learn how to determine the resistance of two different types of resistors. We have THD resistors and CMD, and you want to figure out the resistance of these resistors by looking at color bonds and also like the codes on CMD resistors. In part B, you will be introduced to Tinkercad, which is a web-based software you can use, and you can use breadboard to actually design a circuit, and then you can measure the current, the voltage across any elements of the circuit, and also check the Ohm's law for that. You can see objectives here. The first part is determine the resistance of THD and SMD resistors, construct a circuit on breadboard using resistors, and then use a digital multimeter DMM to measure equivalent resistance and verify Ohm's law. If you go to procedures part A, um, as all labs, you can see lab report template and lab report formatting guidelines. If you click on them, you will be directed to those template and guidelines. And in part 3, you can see the lesson labs. As you can see here, they are clickable. If you click on them, you will see the lessons. The lesson about resistors for part A is explaining how to figure out the resistance of resistors by looking at the color bonds or the code on top of them. For SMD resistors, you will see some examples here and the resistance of those resistors. As an example, if we have a 3-digit resistor, like 2, 2, 3, two first digits are next together, and the last digit is going to be the exponents of 10. So in this example, the resistance is going to be 22 times 10 power to the third. So it's going to be 22,000 ohms or 22 kilo ohms. If you have a resistor with R in the middle and some digits, that R is like a decimal point. So the resistance of this resistor is 4.7 ohms. If you have 4 digits, then the first 3 digits are next together and then times 10 power to the last digit. So in this case, we have 820 times 10 power to the second, which is 82,000 ohms, or we can just use the prefix, so 82 kilo ohms. And in this case here, we have 0R22. Again, R is like a decimal point, so we have 0.22 ohms for this one. And another type of resistors are THD resistors, and there are some color bonds. There's a Wikipedia link here. If you click on this Wikipedia, you will be directed to more explanation of these resistors. But the way it works is these resistors have 3 color bonds next together, and there is another color bond with a distance from those 3. And for each color, we have a number corresponded to that color. As an example, for black, we have 0. Then we have brown, red, orange, yellow. So you can see also the numbers related to those colors. And the way we are going to just read the resistance of the resistor is the first 2 digits are next together. As an example, for this one, we have brown, and then we have black. So it's going to be 1 and then 0. So these two together becomes 10. And then the third bond is 10 power to that number. So the third bond here is orange. We know that the orange has the number of 3, so it's going to be 10 power to the third. So the resistance of this resistor is going to be 10 times 10 to the third. And the last one, the last bond is actually the tolerance, is plus minus something. And you can see the tolerances here. This Last one has limited colored, like we have silver, we have gold, red, and brown. You can see here we have gold, so it's going to be plus minus 5% for that. So it gives us the resistance of the resistor by looking at three first bonds, and the last one gives us the tolerance. And down here, there is equivalent resistance explanation again, is a review of what we covered in lecture. If there are two resistors in series, we can just add them together to find R equivalent or R effective. If they are parallel, then this is the formula we use. 1 over R effective equals 1 over R1 plus 1 over R2. And if there are only two resistors that are parallel, we can just solve this equation for R effective, and this is the formula we will have. R effective equals multiplying those two resistors at top of the fraction and adding them at bottom of the fraction. And it gives us R effective or R equivalent for parallel resistors. After just working on just reading this lessons, you go to part 4, which is a table of some TH2 resistors. Part A, B, and C gives you only the colors, so you can see like brown, black, red, and gold. So based on the color codes, you are going to just write it down in front of that in second column, the resistance of those resistors. And then there are some pictures of these resistors. So you are going to just check the colors and based on the colors, find the resistance of the resistors. And the next question is actually giving you a CMG resistors. You can see here in this board. And also there are listed here in a table based on the codes you can see here. You are going to just write down the resistance of these resistors here. And the second procedure part, like in part B, we have another procedure. Again, there is a lesson part. If you click on this, then you will go to the lesson part. In lesson part, there is explanation about breadboard here. You can see like the connections of rows in breadboard. You can see in like row number 1, all these holes are connected together, and row number 2, they are connected together. There is a gap here between the left side and right side of the breadboard. It means there is no connection between those left side and right side holes. But if you go to the other side, again, rows are connected together. And this is actually what you are going to work with in Tinkercad. If you go down, you will see some explanation here about like nodes, like resistors in series and parallel. There's explanation here how to actually find the resultant or effective resistance. First of all, these two are series and then parallel with R1. So something similar to what we had in lecture, but there is just a review here you can see. And here is a like schematic simulation. You can see just connecting this actually amp meter here to figure out, or like the actually figuring out the equivalent resistance here. And if you just scroll it down, you will see here more explanation about breadboard, how it works, how we can use like this breadboard, putting resistors on it, connect them together, and just read the equivalent resistance of them, or using a voltmeter to find the voltage of like across the circuit or across any elements of the circuit. And also the way you can connect a amp meter. If you want to just read the current, you need to put the amp meter in series, so it shows you the current. So this is one of the lessons you will see here. There's another lesson also here is explained about electrical circuits. In general, there's a battery, resistor, and the explanation about Ohm's law. As an example, here we have a battery with the voltage of 3.3 volts and resistor is 160 ohms. And there is an explanation here how to calculate uh, the current through the circuit by using Ohm's law. Here we have a circuit simulation. If you click on it, you will see the simulation of the circuit and how it works. And as you can see here, the voltmeter is actually in parallel to show the voltage across this element here, which is in this case is LED. So if we go back to procedure part B, after just checking the lesson, you will see a circuit here. In this circuit, there are some resistors connected together in parallel or series form. At the top, we have VCC, which is actually the positive voltage, and down here there's a ground. So like R2 and R10 are connected to ground. Ground has a voltage of 0. So you can have the assumption like VCC is the positive pole of the battery and ground is the negative pole of the battery. And what you need to do is redraw the circuit in a standard form, the way we just talked about in lecture part. And then you are going to figure out series and parallel resistors and you will simplify them until getting one single resistor, which is equivalent resistor. So you actually are going to redraw the circuit, simplify it, and find the equivalent resistance by hand. And then we are going to have 5 volt as a power supply. So here is like 5 volt and here is 0. Based on that 5 volts and finding the equivalent resistance, you are going to use Ohm's law to find the main currents of the circuit. So this part is all should be done by hand. So you are going to calculate them. And then we are going to use Tinkercad to actually uh, make the same circuit in breadboard and check the numbers we already calculated here. There is a link here how to create an account. It's a free web-based software. Simply, you can just use your PCC email to create an account and use your account to work with actually breadboard. And I'm going to show you how to get to that app and how to use that software actually. So I already opened it here. When you create an account, this is my account here. If you don't have any project here, it's when you just create an account, it's empty here. But there is a button here, it says create. When you click on create, there are 3 different options. You are going to click on the middle one, which is circuits. Then it will open for you actually this workplace. And if you look at the right side, you will see the tools and all components you have and you can use. It's automatically in basic mode. You can click on this drop down menu and change it to all so you have access to all elements here. And there is a breadboard here. You can just use this breadboard. This is what we want to use. You can just drag it and drop here. And up here, you can see this button, a rotate button. When you click on it, you can just rotate it at any orientation you want, and you can just move it around any place you want to have it. And then also, you can see resistors at top. So if I drag it here, it shows me a table. You can give it a proper name. As an example, I can say R1 for that. And you can give it a resistance, let's say like 100 kilo ohms. And as you can see, when I change the resistance, the color bonds automatically will change to match the number I put here. So let's say like this is 100, and then I can just move it here and just place it in here. If I put this resistor here and then another resistor, give it another name, let's say R2 and 10 kilo ohms, and I just move it here. If I put them here in a way that the top side are in the same row, the bottom side in the same row, automatically they are in parallel. So as we said in breadboard, the rows are connected together, so I don't need to make a wire between them anymore. So automatically these two are right now in parallel for. If I want them to be in series, I can just put one of them here, another one can be here. You don't need to put them necessarily in the same hole. If I put it here, they are still in series because we know that there is a connection here. And also, in order to uh, give it a power supply, there is a battery. The battery is 9 volts. You can use the battery. As an example, I can just bring the battery here. There are two poles, and you can just create a wire and connect it to like the negative to negative side and positive to positive side. Or you can actually, let me delete this one. You can scroll it down and then be looking for uh, actually this power supply here. If you drag the power supply, you can see that the voltage and the current. So you can give it a name for the power supply if you want, and also you can set a voltage you want. And based on what we have here, we want a power supply to the circuit and set the voltage to 5 volts. And you can just put 5 volts on for it, and then there are two positive and negative poles here. You can just create wires, positive to positive. It can be any of these. So you can see the positive vertical lines are connected together. It shows you what poles are connected together. And then, so I can just click on here, then the negative to here. So right now we know that this is the positive and negative is like 5 volts, the difference between these two poles. And then I can start from positive, make a connection from here, like to here. So it's actually it's positive 5 volts here right now. So based on this actually rules we have for breadboard, you can actually make any circuit in breadboard. I already created a breadboard of this circuit. So you can just as a hint use this and then create your own breadboard. Just try to make it organized. As you can see, like I have these resistors all vertical, all wires are straight. So you prefer to not having some wires like inclined. So you want it to be all like organized like this. And um, the rules you need to follow for using like if you want to read the currents, make sure that you need to use the amp meter in series form. So as you can see, from positive the wire goes here, and then from the negative pole it goes to the circuit. It means that this amp meter is in series. If you want to find the voltage, the voltmeter should be in parallel form. You can find that multimeter actually here. This is multimeter. If I drag it here, there are 3 different parts for measuring current, voltage, and uh, resistance. There's a drop-down menu on it, so you can change any of them. So if you want to just read the current, you go to amperage. If you want to find voltage, you go to voltage and also resistance. And as you can see here, it will be marked here. So you know if it's in like measuring current or voltage or resistance. So you are going to just double check at the end. The current you will get here should be the same current you calculated here. And also R equivalent should be the same as R equivalent. You can just read here by using actually um, this multimeter.